Let's talk about number system, which is sometimes called number-based arithmetic. The basic idea behind this topic is that it's just like a way of expressing the digits that makes up a number or a value with the means of a positional notation or with their corresponding place value. We have several ways in which numbers can be experienced by the means of positional notation. However, we are going to focus on the most common four systems of expressing numbers as or by the means of positional notations. So the first one is known as the binary system. For the binary system, it consists of just two digits, and these digits include 0 and 1. All digits that ask to mix up a number or a value that is in binary system must not include digits that is more than 0 or 1, and its base is simply 2. So which means I can have a number like 101 to be in base 2. This is absolutely right. The next type of system that we need to be familiar with is known as the decimal system. In this system, digits that ask to mix up value in the system must not be more than 9, starting from 0, then all the way to 9. Then we can have numbers like that in decimal numbers. An example of that is when you have something like 50 to be in base 10, 507 to be in base 10. This is an example of decimal system or numbers in decimal system. However, there are some scenarios whereby the base 10 will not be associated with the value. In this case, you need to assume it is still a decimal system. So the next one is the octal system. For the octal system, it consists of values or digits from 0, 1, 2, 3, 4, 5, 6, and 7. It doesn't exceed 7, and its base is simply 8. So I can have a number like 123 in base 8. This is absolutely right. And for the last one, we know as hexadecimal system. For this system, something changes. It consists of numbers from 0 to 15. However, when we get to numbers or digits that consist of two digits, we don't write it as 1. Here's how we express it. So it started from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, instead of having 10 in hexadecimal numbers, we don't have it as 10. We have it as a letter A, typically an uppercase letter. Then having 11, we have it as B. Having 12, we have it as C. Having 13, we have it as D. Having 14, we have it as E. And having 15, we have it as F. So this is how to express hexadecimal number that is more than 9. Please make sure you keep that in mind. Now, there are some basic things I want you to know about the system. For any value or number that is in a particular system, all the digits that has to mix up that value or number must not be more than the base. What am I saying in excess? Let me try to create enough space. Okay. So what I'm saying in excess is that it is impossible for me to have 102 in base 2. This is absolutely wrong. Why? 2 is among the digits that makes up 102, and 2 is up to the base. This is absolutely wrong. We can never have something like that. All the digits that ask to mix up that value or number must not be more than or up to that base. That is why for the decimal, we have digits to be from 0 all the way to 9. And for octal, we have the digits to be from 0 all the way to 7. And for hexadecimal, we have to from 0 all the way to 15. You can see we don't get to 16 or exceed the particular base. So it's something you want to keep in mind. Another thing I want you to know about this base is that we human beings are those that work with decimal system, like numbers, thousands of numbers, millions of numbers. They are all in decimal systems. That's why I said when a base is not assigned to a number, then you need to assume it is a decimal. It's in decimal form. But for binary system, it is computers that understand binary system. It is computers that work with binary system. And for the other two, which is the octal system and the hexadecimal system, the purpose of introducing those systems is due to the human being memory. It's just a way of making our interaction with the computer to be very, very easy, as they are pretty much shorter to work with than the binary system, because one octal system corresponds to 3 digits of binary system, and one hexadecimal system corresponds to 4 digits of binary system. So that's a very good idea. And that is it for this video. So in the next chapter or in the next video, we are going to be focusing on converting from a particular base all the way to another base. Hopefully you find this content helpful. If you haven't subscribed, please do subscribe to my channel. Thanks for watching. See you guys in the next video.